Hello everybody, and welcome back to another CIV E 398 assignment tutorial. So in this assignment tutorial, we're going to be covering question number 4 of assignment 3, and it's actually a very easy question. And I'm hoping that this will be my shortest YouTube video ever created. I'm going for the speedrunning world record on this one here. Question's very simple, and it says if a 3D cube is rotated 69 degrees, and I know you guys are thinking, nice, rotated 69 degrees clockwise about the E3 axis, determine A, the deformation gradient F, B, if the deformation is physically possible, and C, if the deformation is characterized by expansion, contraction, volume preservation, or none of the above. So if I were to look at this really quick, I'm saying, well, B and C I know how to do. All I need to do is define the determinant of F. This was covered in question 2 as well as question 3. So you guys are experts at that. The only thing I need is the deformation gradient. How exactly do I figure that out? Because with that, I can find the determinants, and then part B and part C are a piece of cake. So it's just part A that's a little bit sketchy. Because if we look at this, we're not given any position functions. All we know is that we have a cube, and it's rotated 69 degrees. So we come here and say, well, in order to determine the deformation gradients, we need a position function x. We need x1, x2, and x3. So here's kind of the trick to this question. We have to realize that for a rigid body rotation, the position function can be expressed as x is equal to q times x. And q, well, that's our rotation matrix. So you guys know the rotation matrices. You guys know which q to use in this case. And the second part is that big X. And in this case, x is just going to be equal to x1, x2, and x3. So I can find my position vectors, or sorry, my position functions x1, x2, and x3 by just taking my matrix Q, which again is our rotation matrix, you guys should know that, and we multiply it by big X. But as you guys will see, I'm not expanding it. Normally I like to expand these questions out for you guys so you guys can see exactly how it's done. But what you guys will see is there's a very unique property that we're going to find when we multiply Q by X and then take the partial derivatives. So that's what I want you guys to do. I want you guys to do it. And I want you guys to compare your rotation matrix Q to the deformation gradient F. And as you guys will see, there's something very, very special. And because because of that special property, you guys will also very quickly be able to determine the determinant of F. So again, that's all there is to this question. It should be the fastest question, speed running world record pace. You guys can time your splits and everything. You guys will be good to go. So thank you guys so much for listening to this. I think I got the world record. We'll find out on time. So again, thank you guys so much for listening. I will see you guys in question number 5.